Assalamu alaikum. This is our community project. Today we are going to show our Reddit audience, and we are going to ask them question, and then they will ask the question to us as well. Then so let me introduce myself. My name is Nayan Hamulhaq, and my matrix number is 213904.
Hello, my name is Wasik and my metric number is 218416.
Hello, my name is Rafaf and my metric number is 218503. Okay, before we begin, can I ask you guys your names?
My name is Ziad from Electrical Electronic Engineering, Percy.
My name is Abdulaziz, Chemical Engineering, Percy.
My name is Mohammed Tariq. I'm from industrial design. I am third year.
Ahmed from Mechanical Engineering Department, second year.
So today we're going to be demoing simulation of a radar. So the way radars work is they send out radio waves which are then reflected back. We know the speed of radio waves, the electromagnetic waves, so they move at the speed of light. And we measure the time it takes for it to hit the target and come back. Since we only want the time it takes for it to reach the target, we'll divide them in half. So we have the quantities, time and speed, so we can use that to find the distance between the radar and the object. So in this demo, we're using an ultrasonic sensor to simulate radar. It's not exactly radar because it's not a radio wave, but it works under the same principle. So as you can see, when I put an object in front of it, the red areas show where it's detecting the object. It sends out an ultrasonic signal, and when it comes back, it uses the same calculations I previously mentioned to determine the distance between the object and the sensor. Do you guys have any questions?
Okay, guys, if you have any question, you can ask me and I'll will try to answer any of the questions. Who's gonna go first?
So, what's the maximum distance, and can you increase the distance?
Yes, for this sonar, this is actually a sonar, so it's using sound waves. And for this ultrasonic sensor, the maximum distance is only actually 40 centimeters. If you can see on the screen there, and if you put the bottle further than 40 centimeters, it won't be able to detect it. But in an actual radar, which is using electromagnetic waves, and as you know, they travel at the speed of light, so they're very fast and they have a very long range to detect any incoming planes or any other body in the air or on the ground. So that's how they work better than this one. This one is just a sample. So yeah, there's your answer. Anyone else want to? Yeah.
I see in the screen it's only 100 Can you make it 360?
Yeah, we can. So this servo you see is actually a 180 servo. It only rotates 180 degrees. There are servos that can actually rotate 360 degrees. So if we use an ultrasonic sensor on that servo, we would be able to make the radar 360 degrees. But since this is only a demonstration, this should be enough to demonstrate how radars work. In actual, in airplanes, the radars they have is 360. So you can tell when you're in a plane, you can tell if someone is behind you, someone is to your left or right, front. That is your answer.
I have one question. Is it the same device that's used in aircraft?
So no, this is an ultrasonic sensor. The difference, as we've explained, is aircrafts usually use radars with radio waves. This one uses sound waves. But yeah, that's the difference. And the range is also different. The range of motion, like you just explained, you would be able to go to a full 360 degrees. You'll be able to detect objects much further. But yeah, radio waves, unlike sound waves, they don't get obstructed by any of the air conditions, any particles of dust in air. So radio waves are typically better than ultrasonic for this purpose.
I have one more. What did you do exactly to set this all up?
Okay, so to set up this device, we connected an ultrasonic sensor to a servo motor spinning 180 degrees, and that will connect it through an Arduino into this processing software, where we made a graphical visualization of what the ultrasonic sensor sees.
Okay. You guys have any other questions, or is that it?
I have a question for future.
Yeah.
If you want to make it professional, what is the different they can do it?
If we want to make this a professional or a real one. So for a real one, like you said, first off you just change your sensor. This one is the sonar sensor, ultrasonic sensor, which uses sound waves. So a real one should use electromagnetic waves, radio waves, like you said.
What did you mean? Real life means where? Is it in the RC car or in the real plane? Real plane? No, that's different.
Like he said, that's different. They use different waves because when you're there, up there, sound waves are not ideal for you to use. They can't go far enough, and even for your safety or for military applications, you need electromagnetic radio waves to detect stuff. So that's how you can make it into a more professional one.
Or if you were saying like for the RC cars, then you can use it. Then when the RC cars detect the object, it turns right. So for that you can use this kind of.
Yeah, well, so is there a possibility of an error?
There is a possibility of error. How you want to answer this one? It's fine, it's fine. No problem.
So is there a possibility of an error, like things that it can't detect or maybe got disrupted by some kind of magnet?
For ultrasonic sensors, like I mentioned before, it can be disrupted by air conditions and any particles in the air. For electromagnetic waves, the radio waves, it usually doesn't face these kinds of droplets.
And it also has a blind spot. Let's say it's 180 degree, right? In the behind, you can move anything. It will not detect. So that's the error as well. So when it is 360, if the object is very fast and before it goes to the another side, if the object is already past the radar, then it cannot detect. So that's also error. Then let's say the B-2 Spirit American fighter, that bomber plane, the radar also cannot detect that plane.
Not even a fast traveling object?
No.
Fast traveling, because you see radio waves, they travel at the speed of light. Nothing is faster than that. So if your radar can emit waves like that and reflect it back, so it should be easy to detect even on fast moving objects. But then again, this is not very simple technology. The ones you have in military aircraft right now is very advanced. It's not as simple as just one circuit board and you connect the wire and detect like this. So yeah, this is just a very the simplest of the simplest circuits, just for you to understand how radars work. So I think that's it for this video.
Okay, this is the end of our demonstration class. So if you have any further questions or any inquiry, we will send you a Google form. Please let us know if you have any other questions. That's all from us. Assalamu alaikum. Thank you. And thanks for coming.
So thank you. Thank you.